So let's do a couple problems where you take the velocity when it hits the ground. So let's take the first one. The first one is you want to know what the velocity, and it says dropped, which means it's not given any initial velocity. So V0 is 0. Vf is what you want to know. And the acceleration is now g, which is 9.8 meters per second squared. So Vf is equal to V0 plus gt. And in this convention, actually g is minus because it directs downward. So Vf is going to equal 0 plus 9.8, a minus 9.8, times 1, or minus 9.8 meters per second, which means it's traveling down at minus 9.8 meters per second. What is the final velocity? Okay, there's a couple ways that we can do that. Probably the best way to do that is to look at it this way. Vf squared is equal to V0 squared plus 2g times the y displacement, okay, which is yf minus y0, okay. We know that and we want to find Vf, okay. So Vf squared is going to equal, the initial velocity is 0 plus 2 times a minus 9.8 times the initial, it's 75 meters, so it's minus 75 because it's falling, minus 0. So if we take this, now that's squared, right? So we need, if we want Vf, we have to take all of that and take the square root of it. And so if we take 75 times 9.8, and the two negatives there cancel each other out, times 2, and we take the square root of that number, we get 38.3 meters per second. So the velocity when this object that's dropped hits the ground is 38.3 meters per second. Minus 38 point. No, it's plus 38.3 meters per second. Actually, it should be minus, but you can't get a square root of minus number. No, that's plus. That's plus over there. I'll have to think about that sign, but it should be minus 38.3 meters per second because it's traveling down. A coin is dropped from a hot air balloon that is 300 meters above the ground and is rising at 10 meters per second upward. For the coin, find the maximum height reached. Find its position and velocity 4 seconds after being released. Okay. Now it's not dropped. In this case, and this is where the tricky is, first of all, you know that the y displacement, so yf minus y0 is 300 minus 300. Okay. The coin is initially traveling, so V0 is 10 upward, so it's positive. and g doesn't change. It's 9.8 and it's negative meters per second squared. And t, the second t in here is 4 seconds. So the first question they've asked is find the maximum height it's reached. And so it's 300. Let's draw a picture. It'll help you see what I'm talking about here. So here's the ground. Here's the balloon, okay? Initially it's going to go up and then drop, okay? And so let's write some of the equations down that we know. We know that the y displacement is going to equal to v0t plus 1/2 gt squared. We also know that vf squared is equal to v0 squared plus 2 times g times the y displacement. I'm writing these down because I'm trying to figure out which one of these is the better one to use. Okay, at the maximum point, this thing goes up until gravity eliminates all its velocity. So at this maximum point, the velocity is equal to 0. So if we use this equation and set Vf equals 0, that will tell us this, okay, because we know everything else. So if Vf is equal to 0, and that equals 10, this is squared, plus 10 squared plus 2 times 9.8 times this displacement. And what this displacement will be added on to this. Okay, so if we put that in, we know that minus 100 is going to equal 2 times minus 9.8 times y, which is the change. And if we eliminate the negative signs, so y, or how far it goes up beyond 300 meters, is going to be 100 divided by 19.6, or 5.1 meters. So the maximum height is going to be 300 plus 5.1. Okay? So the maximum height it reaches is 305.1 meters. And at this point, that's this point right here, we start falling. Now the time it takes it to do that, again, we can calculate that in a couple of different ways. We can calculate it by, we know everything in this equation except t, or we can use something even simpler. Vf is equal to v0 plus gt. So that's 0 is equal to 10 plus 9.8 times t. And so t is going to be just a little bit over 1 second. So it's 1.02 seconds. So the falling time, so it falls from 305.1 meters, and the falling time is going to be 4 minus 1.02, or 2.98 seconds. So we start at this point, and we're allowed to fall this far. And so if we put that in, and it wants to know the velocity and position at that point, again, we can use this, okay, because we know at this top V0 is now 0. We know this and we know G, so VF is going to equal to 0 plus 9.8 times 2.98 seconds. That's what's left. It's a minus 9.8, so VF is going to equal minus so it's going to be falling at 29.2 meters per second, and Y is going to equal, first of all, we'll say the change in Y is going to equal, using this equation right here, again we're starting from up here, V0 is 0, so that first is going to be 1/2 GT squared, so the change is going to be 1/2 times 9.8 times 2.98 squared, which is equal to so the change is 43.5 meters. So the change in position goes from 305.1 and subtract 43.5. So it's 261.6 meters above the ground. So that's the new position after 4 seconds.